Hello, loyal viewers! The armored dinosaurs were some of the most magnificent and intimidating of the terrible reptiles to ever grace this planet. While the diversity of their forms ranges from the enigmatic to the brutish, I think it's pretty safe to say that the most basic of these is Stegosaurus. Being one of the earliest known of the Thyreophorans and gracing shelf, screen, and coloring book, Stegosaurus is without a doubt one of the most ubiquitous of all dinosaurs. Yet with popularity often comes being taken for granted. Stegosaurs are already really weird for their tiny heads, bristling tails, and immaculate displays. Yet despite its over 100 years of research, overexposure, and seemingly more interesting relatives, I think that the morphology, history, and ambiguity surrounding Stegosaurus makes it the strangest of them all. And the main reason for that is the plates. Because this is of course the Ichthyovenator channel, that means that I, Nolan, will be here and giving you a taste of this through art. So strap in. This is going to be a bit of a doozy. Stegosaurus was first exhumed from the eroding eastern slope of the Rocky Mountains in 1877, where they would get their name and description from one Othniel Charles Marsh. The skeleton included limb elements, vertebral material, two tooth types, compressed and cylindrical, and a large dermal plate being over 3 feet long. Most descriptives were vague and brief. The plates were likened to the scutes found on Atlantic Hellies, and thus the name Stegosaurus armatus was erected. An interesting note is the cylindrical teeth were actually noted to have the possibility of being dermal spines. Marsh's original idea would be illustrated twice from what I can see, the first being this famous work by French artist Auguste Jobin in 1884. The second would be Frank Bond's Pangolinosaur in 1899, as commissioned by W.C. Knight. The latter's more recent date reflects its closer shape to the era's Stegosaurus. What's interesting is that neither of these illustrations actually fully matched Marsh's original description. Jobin's actually lacks the plate, which is what gave its name in the first place, while Bond has the plates, but they look really strange. I don't know, they look more like a pangolin than the plates of an actual turtle. Of course, you may be wondering why these two illustrations are bipedal in the first place, and that's simply because bipedalism was somewhat of a norm back in the late 19th century, with American dinosaurs being depicted as bipedal from Laelaps to Hadrosaurus, and indeed, even with people who normally would depict dinosaurs as quadrupedal, like Benjamin Waterhouse Hawkins depicted Hadrosaurus as bipedal. So it was just a convention at the time, really. And sauropod descriptions hadn't been quite so complete, so we didn't actually know too much about how some dinosaurs had to be quadrupedal. In order to consolidate the two, I made my own reconstruction of Marsh's Stegosaurus armatus here, which I think better illustrates both, and it was quite fun to draw. I remember a bunch of fun comments on it, yet both of these illustrations were quickly outdated and anachronistic, as in the following years Marsh would refine his roofed reptiles further. Now Stegosaurus is fairly unique in its defining feature, that being the morphology of its plates. Stegosaurian clade diverged from the other Thyreophorans in the mid-Jurassic, where the Ankylosaurs took what the more basic forms like Scutellosaurus, Amausaurus, and Solidosaurus evolved, and further bolstered it into the tanks they would become. Stegosaurs pulled a Miles Morales.
I'ma do my own thing.
Their dermal scutes became highly modified into the spikes and plates we know and love. Now each form of Stegosaur has unique dorsal arrangements, but they generally cluster into two groups. Small plates, leading to spikes, and small plates just all around. Stegosaurus and its closest relatives buck this trend and bring out two anomalies: giant plates and an alternating arrangement. But the road to understanding this morphology was just a little bit complicated. The Stegosaurus I'll be depicting here is a lone male Stegosaurus stenops in a drought-like situation, and I'm basing this off of the Cleveland Lloyd Dinosaur Quarry, an assemblage with an insane diversity of late Jurassic Morrison fauna, the most famous of which is the bajillion Allosauruses we have from there. The fact that most of the bones are predators has led many to believe that this is some sort of predator trap, like the La Brea tar pits, and this is actually what's alluded to in the Ballad of Big Al, with the large female Allosaurus becoming trapped after finding a desiccated Stegosaurus that died from some mud. However, more recent research has brought to light some other possibilities, but what seems to have actually happened is multiple different attritional depositions of fauna because of flooding and seasonal droughts. This appears to have been some sort of ephemeral pond, which means that it was not a permanent water body, and that's why we don't see any fish. And because of this, animals would come here to drink and whatnot, and when it's dry, there isn't exactly much water. Of course, when flooding did happen, the water that would inevitably fill up this ephemeral pond would have a bunch of creatures thrown into it as well. The Stegosaurus is going to be out here wandering the desert looking for any type of resource, while under the ground, a kaleidoscopic diversity of Morrison formation animals is just out of sight. (1879) saw Marsh's second Stegosaurus species being named, Stegosaurus ungulatus. In his quick description, we see the beginnings of some lasting interpretations of the animal. Where the plates are concerned, we get a departure from the comparisons to giant turtles.
That is bad news.
Marsh doesn't elect to actually attempt any configurations of the dermal armor, just their existence and individual structures. Ungulatus has decently tall plates, with the largest being over a meter in length. Jump to the arrival of Stegosaurus, Stenops, and Sulcatus in 1887, and we start to see some interspecific variation, which I'll get to further on. Around this time, the arrangement of the plates as tall structures along the back became clear, and in 1891, Marsh would finally give his take on this animal. The skeletal reconstruction depicts Stegosaurus ungulatus, and we've got some distinct characters here. There are only 12 plates along a single row, and to accommodate this, the back is super arched to make room, and even then, it's very cramped up there. This is apparently based on what they perceived as the known position of the dermal armor on Stegosaurus stenops. The 1890s would continue the single row reconstruction until what would undoubtedly be the most influential of all Stegosaurus imagery. In 1901, Frederick Lucas would commission the legendary Charles R. Knight to paint his seminal artwork of Stegosaurus. Knight had actually depicted Stegosaurus before, following Marsh's skeletal more closely, but Lucas wanted to visualize his hypothesis of a pair of dorsal plate rows instead of just the one. However, his preliminary view of this arrangement was that of mirrored plates. A point from Menospondylus's blog that I agree with is that this assumption is honestly understandable since they'd be going off of bilateral symmetry. It's funny how years later this would once again cause some trouble with Styracosaurus. Lucas would later revise his theory and propose the alternating plate arrangement, which was a lot more solid for a couple reasons. The first was the fact that the plates of Stegosaurus were chiral, meaning they didn't match their mirror image. Yet this mirror form could still theoretically exist unlike a purely asymmetrical form. Unless every specimen of Stegosaurus happened to not preserve each pair, it just wasn't reasonable. The other is the discovery of articulated plates in Stegosaurus stenops, preserved sediment between the plates, both confirming the double plate hypothesis and the alternating plate hypothesis. The latter discoveries wouldn't be known for decades, so the paired plates were still held onto for a bit longer. Richard Lull would continue the paired plate in his mount of Stegosaurus ungulatus, made for the Peabody Museum of Natural History in 1910. There was a mixture of ungulatus and Stegosaurus duplex elements used, but of course those are actually the same species now, so that's really just saying ungulatus twice. Of course, because he ran into the issue of the plates lacking mates, it was necessary to sculpt those hypothetical plates. And this style of plates would remain a bit in pop culture, most significantly in the original King Kong and Disney's Fantasia. Charles Gilmore wrote on Stegosaurus in 1914, and gave what would be the most recent description for 99 years. He agrees with Lucas on the plate structure, and adds the modification of moving the largest plate from over the hip to above the base of the tail. Stegosaurus would remain in this plate position, scientifically speaking, for the foreseeable future. However, the most ridiculous of ideas would be brought to light in 1920, when one Dr. W.H. Blau proposed that Stegosaurus was a gliding animal, using its hollow bones for lightness and achieving lift through its plates, which it could hinge laterally like in this illustration. A beautiful example of retro-dino absurdity, like the fire-breathing Parasaurolophus or McLaughlin's Triceratops. This literally only appeared in a newspaper strip, so it's safe to say this wasn't taken seriously. In 1987, Stephen Jerkas, in the book Dinosaurs Past and Present 2, proposed a return to the old restoration of a single row of plates. He found out the bases of the plates were able to fit in a single row, but the more broad, higher portions would overlap. His solution was tilting the plates to either side. This reconstruction's longevity is understated, with both a Kenner Jurassic Park toy and even the mounted skeleton of Sophie, a specimen that will become extremely important for Stegosaurus biology a lot later in the timeline, possessing this configuration. Jerkas apparently compared this arrangement to the spikes on some modern lizards, and further thought it would amplify the plate's usage as thermoregulatory structures. Scientifically, this never really caught on. Now, you might think nothing came from the gliding stegosaur hypothesis.
You're correct, sir.
However, in the era of the dinosaur renaissance, we saw one more instance of wacky plate dynamics. This would be Stegosaurus having the ability to actively control its plates. This was featured in Robert Bacher's book The Dinosaur Heresies in 1986, which I still need to read, but it also appeared in an animated form in the 1992 television series by PBS, The Dinosaurs, as some sort of threat display towards a hungry Ceratosaurus. Bacher supported the idea of the plates being used for defense, and perhaps them flattening over the body would be better protection. I don't think this has been properly rebutted in a paper or something, but this idea has been thrown out with the musculature not really being possible.
So what's his name again?
Mount Kilimanjaro. Watch how he can do a flip. Wait, hold on. Oh. Okay guys, this time, really. This time, really.
Suck. For the color scheme of this stego, I'm doing something a bit unconventional. In most artworks we see, there is a very general trend, which is green stegosaurus with red or orange plates. It's one of those constants in paleo art, and it's one of those constants in paleo art and seems to be the most prevalent of these paleo art memes. Here, I am depicting the actual animal to be more colorful than the plates, because in nature, often contrast is just as effective as a display when it comes to displaying, and of course, I just wanted to do something a bit different. In terms of color references, I just wanted to put a new spin on that red and green trope. So I referenced the caiman lizard, red tegu, and plumed basilisk. I chose lizards specifically because lizard skin is a bit more pebbly in texture and the scales tend to be smaller in size compared to, say, snakes, which are a type of lizard, and crocodiles, which have really big scales. But wait, why do we think these plates were for display? Well, my dear viewer, this is actually just the most recent of our hypotheses surrounding their function. Originally, the plates were considered dermal armor, and it's why Marsh named the animal armored root lizard in the first place. This idea would remain all the way through to the modern day to some degree, with it being decently well supported. After all, these plates would pose a major hindrance to any theropod attempting to bite the animal, and even a predator with a gape as wide as that of Allosaurus would have a hard time getting around them. However, if this were the only function, you'd expect the plates to have some sort of consistency across species, I would think. Yet Stegosaurus is one of the few stegosaurs that don't even have dorsal spikes, which I think would be far more effective. The other primary idea for Stegosaurus's perplexing plate's purpose was thermal regulation. This was a super common idea all throughout the 20th century, and pretty much any prehistoric animal with noteworthy projections from the skeleton fell into this. The idea being that they could soak up heat when in the sun and radiate excess heat to cool off. Again, this brings up the vast differences in stegosaur plate morphology and how some would seemingly be horrendous at this task. Kentrosaurus has half of them being spikes, which don't seem like very good thermoregulatory devices to me. Might as well throw in the Bagamizer as well. But the real disqualifying factor was the integument of the related animal Hesperosaurus, which was the former Stegosaurus mjosi. The plates of the animal were found to have a smooth texture with striations allowing for shallow ridges in life, and the authors in the paper that described this interpreted this to be a keratin sheath, and it pretty much kiboshed the thermoregulatory idea since keratin does a terrible job at that. You know what keratin isn't terrible at though? Display structures, being able to grow in all kinds of shapes and colors. And considering how close Hesperosaurus is to Stegosaurus, we can conclude that it also had this type of plate covering, unless proven otherwise. So display is in, and honestly, the what's this for to display pipeline is so common in paleontology and even modern zoology that this shouldn't really be a surprise. Display is a form of communication, whether as intimidation or as a way of attracting mates, but intra-specific communication isn't the only form this can take. In Walking with Dinosaurs, we see the monster that murdered that poor Diplodocus flush blood into its plates to create a bold display of color which succeeds in intimidating the marauding Allosaurus away. This type of thing seems unreasonable to me with how the plates are covered in keratin instead of skin. What's probably more useful is being able to recognize one's own species, and here we begin to see some diversity within Stegosaurus' different aspects and relatives, which segues us perfectly into talking about the species of Stegosaurus. The valid ones, that is. Of course, Stegosaurus armatus is what started it all in 1877, but now it's actually believed to be invalid. As you can see in my attempt at a skeletal here, the holotype was really scrappy, not to mention chimeric. Those cylindrical teeth were most likely from Diplodocus, along with the other jaw fragments, Allosaurus limb elements, other sauropod material. In 2010, Peter Galton proposed Armatus's dubious nature, with its less than optimal description and lack of proper autapomorphies. It was bad enough that some papers didn't even base stuff off of it. And in 2011, the ICZN accepted this proposal,
Approved.
and Stegosaurus stenops would become the new type specimen, while Armatus became a novum dubium.
No!
The second species to be named was Stegosaurus ungulatus in 1879. This probably was the most relevant species in terms of reconstructions, with the first Marsh skeletal, as well as Knight's influential work. A bunch of other very famous Stegosaurus tropes also rose from Ungulatus. The limb disparity, the kite-shaped plates, the second brain, those were all from Ungulatus, especially with Marsh's clarification of his idea of Stegosauria in 1880. But a note on how to tell if an old restoration is of Ungulatus was to look at the amount of thagomizers. You see, Ungulatus was thought to have been especially unique among Stegosaurus species because it was thought to have 8 thagomizers. Well, of course there were duplicates, but no one really picked up on that for a long time. So if you find an animal with 8 tail spikes, it is almost certainly Ungulatus. In fact, Stenops having 4 spikes was one of the things they used to separate it from Ungulatus. Also, did you know that the term thagomizer comes from a Far Side comic? It's this one. Yeah, that's literally where the term came from. It's scientific. It's brilliant. In 1887, we got Stenops. Being noticeably smaller than Ungulatus, Stegosaurus stenops is the most understood of all these species, hence it being the type species nowadays. Its plates were noticeably rounded and larger proportionally than Ungulatus, and also the limbs are more comparable in size, things that the Sophie specimen really helped bring out. Sophie was a subadult specimen that was described in 2015 by Maidman et al., and it was the most complete Stegosaurus we've found yet, with very beautifully preserved material in 3 dimensions. Sophie's biggest scientific contribution is bringing our understanding of Stegosaurus proportions much more in line with its relatives. The neck is not as short as we previously thought. The limbs are a bit more comparable, even though they are still pretty disparate. After all, the center of mass of Stegosaurus is actually quite similar to many bipedal dinosaurs. The hyper-arched, hyper-exaggerated Stegosauruses of yesteryear are basically dead, even though a bit of a lengthening of the hind limbs and neural arch is possible due to growth allometry. The last, and definitely the most controversial and enigmatic of these species, is Stegosaurus sulcatus, which was also described in 1887. This animal is very peculiar. We don't have a lot of it, far less than the other 2 species, but we have some limb elements, a couple nuchal plates, a dorsal plate, which I haven't seen a figure of, some other elements, but most importantly, what appears to be a parascapular spine, which is the same type of spine you'd see in other more basal stegosaurs. Now this is very interesting because we have quite a few specimens of the other stegosaurus species. In fact, Stegosaurus is the most sampled stegosaur, but we don't have any parascapular spines from the other species. So what's going on here? This species hasn't been looked at recently at all. The last time it was even mentioned in a paper was in 2010 by Galton. He considered it valid back then. There is debate over this though outside of published articles. Like, maybe it's too indeterminate to be a Stegosaurus. Maybe it's not Stegosaurus at all. It's hard to say. And we'll have to just wait and see until someone eventually revisits this specimen, because it's very interesting and very understudied. So at the end of the day, Cenops, Ungulatus, and Sulcatus, tentatively, would remain as the three species of Stegosaurus, and they may have even come across one another. Cenops and Ungulatus were both around 150 million years ago in the same place, so the noticeable differences between their anatomies may have aided in telling each other apart. I do want to make clear a caveat with interspecies recognition, and that is, it's a very complicated subject. Lots of different factors go into this, from behavioral cues, pheromones, times of year when they're active, sound. So much goes into it, and a lot of it is hard to understand for people from an outside perspective, but it's something that is worth noting, even if in modern animals it's difficult to pin down. Which brings me to the reason I wanted to make this video in the first place. Why the hell is Stegosaurus' plate morphology so vastly different from the rest of Stegosauria? The phylogeny of Stegosaurus seems to show a correlation between the basal forms and spikes, but this seems to just be because Stegosaurus is super derived and its close relatives share this. When looking at close relatives to possibly find out how Stegosaurus got to where it is, we run into some problems. A lot of the animals that are reconstructed quite similarly to Stegosaurus are actually so fragmentary that their relation to Stegosaurus is the reason why they're reconstructed the way they are. In terms of completely known animals, Hesperosaurus is the closest we've got, and it actually may have been an anagenetic ancestor of Stegosaurus living a few million years before. Now, Stegosaurus is known from the Morrison Formation and the Lorena Formation, but we don't actually know exactly how they got there or what their ancestors in those areas looked like, because these areas often have very poor fossil preservation rates the further down you go. And that's actually why a lot of the animals in the Morrison Formation especially kind of just show up. So the how isn't quite so easy to understand, but that might change with future research. The why is a completely different topic. Why did Stegosaurus end up evolving this way? And to be honest, the answer might be less than satisfactory, but the answer might just be because it did.
Are you kidding me? Are you kidding me?
Evolution is very messy. It doesn't have a straight goal in mind. Things often just happen because they work, and Stegosaurus' plates, being large and alternating, may have simply been a result of it working. Evolution is just so beyond our understanding when it comes to the why of certain things. Like, we can figure out the mechanisms behind it, we can figure out what drives it, but in terms of why it takes a specific shape, no one really knows. The divergence from Stegosaurs and Ankylosaurs is poorly understood, and the same thing goes for the Stegosaurians and their relatives like the Dawsontrarians. So while an unsatisfactory answer, it's the best one we're gonna get, but we just have to wait and see. While this answer would have really bothered me when I first conceived of this video, I've made peace with it because of how long this took. Well, that was pretty much my piece on this magnificent, albeit confusing animal. Originally, I just wanted to make a video detailing how weird Stegosaurus is compared to its relatives, but I quickly ran into the brick wall of, we don't know why this is, it just is. And that's not very interesting as a video concept, so I thought I would do something a little bit more different, which of course meant this video took way longer than it should have, but regardless, 2 Stegosaurus paintings, a bunch of supplementary drawings, and final exams for university out of the way, this is done. And I want to thank you guys for watching this far. If you appreciate this sort of content, please recommend something I should do like this in the future, and of course, standard YouTube spiel.
Okay, if I sound different, it's because I'm sick, that's why. Okay, this time I swear, guys. Oh!
He did it!